everybody, this is Zoe. Today I'm going to talk about the Pseudo HDR. Basically, the target here is trying to enable an HDR experience for ordinary SDR video streaming. So first, let's look at the video compression processing with intelligent optimization. We're mainly focused on here is the user-generated content when they are uploaded to the cloud before they are packetizing and redistribution to many variable and devices. And the user-generated content, usually they have a big variety in quality, and before they are being transcoded, scene characterization plus preprocessing has been widely adopted. The Pseudo HDR we talk today actually is a module inside the procedure of preprocessing. So what is the Pseudo HDR? We all know that HDR format is very ideal in the sense that provide more white and colorful colors at the same time, especially for significant darker and brighter area. It actually provides more texture and details. However, HDR video formats many times are still constrained nowadays, considering the limitation on the on-device rendering capability as well as the high bandwidth that may be consumed by HDR format. So what we are trying to do here is to provide HDR-like quality video, however, still keep the video in the SDR format. That's why we refer to as Pseudo HDR. So the input down here could be either HDR or SDR. The output of the Pseudo HDR conversion is definitely SDR format, but providing a pseudo, at least a target cell, to provide Pseudo HDR type quality. And the scheme behind it, we still follow the convention for many similar work that has been conducted in the area. In particular, adaptive histogram equalization has been widely used. Multiple histogram has been extracted for different local regions within the video frame, and therefore using the localized histogram transformation to achieve a boosted contrast resulting video frame, then it will be really helpful to improve the local contrast while enhancing the edges. So this is what we mainly use for our Pseudo HDR conversion. On top of it, besides the adaptive histogram equalization, there's also a further contrast limit that generally applied for this procedure, because during such kind of histogram transformation, other artifacts such as noise application may be introduced, with the contrast limit featured by one clip limit parameter, and further better quality, overall quality of Pseudo HDR can be achieved with the potential artifacts largely ameliorated. So based on such kind of idea, this is a procedure we propose. And on top of it, actually, we did one more step, because usually the histogram equalization with transformation are being done in the RGB domain, especially for images. However, for video, many times the input format is in fact in YUV domain. We have proposed a direct YUV domain histogram transformation by leveraging the theory behind probability distribution, together considering the conversion matrix between RGB and YUV channel. And here, this is the equation behind the figures we just drawn in the previous slides, and by deriving such kind of nonlinear probability density functions, we propose a scheme to directly apply Pseudo HDR in the YUV domain without the YUV and RGB conversion. And here, based on all we have just discussed, we propose a flowchart down here, basically to have a Pseudo HDR module with a stress parameter valued between 0 and 1. The larger this value is, the stronger Pseudo HDR effect will be resulted. And on top of it, indeed, instead of taking the output video from the Pseudo HDR directly, we have combined the Pseudo HDR result with the original source video with adaptive weighted summarization. The idea behind is some area regions in the video frame, for example, the skin areas, may not be so ideal to be applied for histogram transformation. Otherwise, the skin colors will easily produce very visible artifacts. Therefore, we actually proactively differentiate between different regions. For example, to applying skin detection to identify those skin regions, and actually weigh less on the Pseudo HDR result, but weigh more on the source video regions. So by applying such a region-based weighted sum of the Pseudo HDR result with the original video, we actually propose a region-based Pseudo HDR result to provide the overall quality of experience while not trying boosting the contrast, basically try to avoid other artifacts being introduced. So now let's show a result down here. This example that we show that on the left side, it is the original source video and fed into the Pseudo HDR procedure, and the red video is what we produce by applying Pseudo HDR. And keep in mind that both videos are in the same SDR format, but Pseudo HDR can produce a better contrast boosted result. And in this way, we further combine the Pseudo HDR module together with the Preprocessing and our overall AI plus codec framework. So in this way, the Pseudo HDR is put inside the whole AI plus codec through the intelligent optimization. For example, some further artifacts that can be further reduced, and also the overall image can be boosted. For example, the Pseudo HDR, we have to consider, because video is a 3-dimensional signal, we have to consider the temporal domain consistency to avoid the flicker type of artifacts. In this way, we actually doing a joint spatial and temporal domain optimization for the preprocessing stage to really enhance the contrast while avoiding the contrast inconsistency in the temporal domain. On the other side, there's also some artifact may be potentially introduced by the Pseudo HDR procedure, like two black-red area, when some textures are manifested, there's some noises, or some bending artifacts may be introduced in the homogeneous area. With the preprocessing stage and also the adaptive video compression, we can use such kind of debending procedure to surpass the artifacts introduced by Pseudo HDR. On top of it, some video may already have a good high dynamic range, then Pseudo HDR should not be applied, so that to avoid further artifacts introducing or try to reduce the overall computational complexity. So we also introduce a contrast-based, very simple categorization scheme when the original video or the regions identified should not be applied with the Pseudo HDR, then you should go directly to the preprocessing procedure, while with the Pseudo HDR procedure skipped. And in this way, right now we can achieve at least as fast as for 1080p 30 videos with a single thread. We can do real processing with the use of Pseudo HDR, and with the whole AI plus codec framework, by applying Pseudo HDR, we can further achieve the same bitrate, but a lot better contrast in visual quality magnification, and or achieve the same visual quality using Pseudo HDR can actually save in many scenarios by more than 10% bitrate savings. One thing we have to address down here is the justification for pseudo HDR, for example, to tune the parameters for a set of category of videos, we still heavily rely on subjective quality evaluation to really tune the parameters inside in the adaptive way. We still really in need of good objective quality metrics down here. VMAP actually a little bit too good to be taken here, because whenever a contrast like Pseudo HDR procedure being considered, the VMAP score could be largely boosted, not quite consistent with the subjective quality evaluation. And we give a result here to show the overall optimization. This is the compare with the procedure with the use and without the use of Pseudo HDR, and to achieve similar bitrate. Let's see the difference in visual quality. So this is the scheme that without Pseudo HDR, and then this is the one with Pseudo HDR to achieve the similar bitrate without and with. It can be seen that is visual quality has been noticeably boosted. That has concluded my talk. Thank you everyone. If you have any question, just feel free to drop me an email. Thank you.